He changed the way we understand the universe. From falling apples to the laws of motion, his ideas still shape science today. This is the life and legacy of Sir Isaac Newton. Born on a cold December day in 1642 in the quiet village of Woolsthorpe, Lincolnshire, a boy entered the world destined to change it forever. Orphaned before birth, young Isaac Newton was raised by his grandparents in a time of civil war and revolution. Though life first led him to the family farm, fate soon steered him elsewhere. Encouraged by his uncle and schoolmaster, Isaac was sent to Cambridge, setting him on a path toward genius. At Cambridge, Newton's restless mind quickly outgrew the ancient texts. He immersed himself in mathematics, philosophy, and in the isolation of the Great Plague years began the groundbreaking work that would define an age. By 1669, he had earned the prestigious title of Lucasian Professor. Through the 1670s, he crafted the revolutionary reflecting telescope, published new theories on light and color, and delved deeply into the secret realms of alchemy and theology. Then a visit from the renowned astronomer Edmund Halley would reignite his cosmic vision, leading to Newton's magnum opus, Principia Mathematica. In 1687, this singular work would forever transform science and enshrine Newton as one of history's greatest minds. But with fame came disillusionment. Weary of Cambridge, Newton briefly served in Parliament, and after years of intense study, a breakdown would follow. Yet from adversity he rose once more, journeying to London in 1696, where a new chapter began, as Warden of the Royal Mint. In London, Newton's influence only grew. As President of the Royal Society, he stood at the center of scientific debate, clashing with rival thinkers, most famously over the calculus controversy with Leibniz. He published Optics, revised Principia, and continued to shape the future of mathematics and natural philosophy. Isaac Newton passed away in 1727 at the age of 84. Yet, through the preserved papers of his devoted niece, Catherine Burton, his voice echoes still in every corner of science, in every question of nature. A legacy without end. Before Newton, telescopes used glass lenses that distorted colors, producing blurred edges. After crafting his own lenses, Newton devised a new solution: mirrors. His design used a large curved mirror to gather the image and a small flat mirror to direct it to the eye. The result was a clearer image in a smaller device. In 1668, Newton built his first model, just 6 inches long, yet able to magnify 40 times. This breakthrough became the foundation for modern telescopes, used today by both amateur astronomers and NASA scientists. Next time you see a rainbow, think of Newton. Before him, many believed rainbows came from water coloring light, or from a blend of light and dark. Newton challenged these ideas. In a dark room, he passed white light through a prism, splitting it into 7 colors, the spectrum we know today. Then he passed the colors through another prism, recombining them into white light. This proved that white light contains all the colors of the rainbow, a discovery that shaped our understanding of optics. In 1687, Newton's Principia Mathematica revealed the 3 laws of motion,
the bedrock of classical physics. His first law, inertia, explains why a moving object continues forward unless an external force stops it. The second law, force equals mass times acceleration, shows how more force is needed to move heavier objects. The third law, for every action an equal and opposite reaction, explains phenomena from rockets to the simple act of sitting in a chair. Principia also introduced Newton's law of universal gravitation. Legend says an apple falling from a tree led Newton to wonder, could gravity affect both apples and planets? He proved that it could. Gravity governs the motion of planets and the tides, and explains why smaller bodies, like the Moon, exert weaker gravitational pull. To describe these forces, Newton developed a new branch of mathematics, calculus, or as he called it, fluxions. Though challenging, calculus became an essential tool for science and engineering, helping us understand a universe in motion.
And if you enjoyed learning about the life and legacy of Sir Isaac Newton, don't forget to like, comment, and follow for more inspiring stories from the world of science.